Hello, I welcome you all in this presentation related to the subject fundamentals of surface engineering, and we are talking about the surface modification techniques, and under the surface modification techniques especially we are talking about those methods which are associated with the change in surface composition for improving the surface properties. So, in this broad category of the surface modification techniques where surface composition is modified to get the required set of the properties. In the surface engineering we normally use the main component of somewhat cheap and the low quality material which is able to take the major load of the system, but the surface properties are not good enough to perform the expected functions for longer time. So, in the surface modification of such kind of the substrate materials, surface properties are enhanced through various surface modification techniques. In one of the technique, a surface and near surface layers composition is modified so that the required change in surface properties can be achieved for expected performance of the component. So, the change in surface composition means we have to introduce the alloying elements, or we need to have those compounds at the surface so that the properties can be enhanced. There are two broad approaches which are used to introduce the alloying elements at the surface and the subsurface layers of the substrates. So, the broad approaches of modifying the chemical composition includes, one is the diffusion. Whatever element we want to introduce at the surface and subsurface of the component, environment enriched with that element is created, so that because of the concentration gradient at a higher temperature diffusion can be facilitated. And there is another approach where the melting of the alloying elements as well as substrate, alloying elements as well as substrate, both is used to introduce the elements at the surface layers. So, what happens whenever we add these alloying elements from outside, either using the diffusion or the melting, the enrichment of the elements in controlled way at the surface and near surface layers can work in different ways. For example, enrichment of the elements can lead to the solid solution strengthening. So, the surface gets hardened and strengthened, which in turn helps in improving the adhesion and abrasive or erosive wear resistance. There is another way, it may facilitate the precipitation hardening. So, introducing some of the elements at the surface layers, subsequently on the heat treatment they form hard precipitates which will help in improving the surface properties. Then we have the dispersion hardening, wherein the such kind of the constituents are introduced at the surface and near surface layers which will maintain their integrity and will get firmly bonded mixed with the surface and near surface layers. So, this kind of situation leads to the case where the surface composites are developed. So, the reinforcing agent in form of the hard particles or particular soft constituents like graphite, they are introduced at the surface layers so that the required change in properties can be realized. So, the dispersion hardening especially utilized when the surface composites are made, and sometimes the alloying elements are introduced primarily to achieve the required intermetallic compounds or the phases at the surface and near surface layers after the subsequent heat treatment. So, this is the approach which is used, like phase modification is used in case of the carburizing So, high carbon martensite we can get in the carburizing, while iron nitrides are formed in case of the nitriding. So, those are the processes where chemical elements are introduced for the purpose of having a particular kind of phase or particular kind of the intermetallic compound. Similarly, we can have the variety of elements in at the surface and subsurface layers of the component, which will be helping to improve the properties through one or combination of these mechanisms for improving the surface properties. There are various approaches for modifying the surface composition and the surface layers of the different materials are developed. So, one method is where the chemical or electrochemical reactions are used. So, this kind of method is used for depositing the nickel or the nickel phosphate coatings and modifying the composition of the surface layers. So, in this case the temperature of the substrate is maintained well below the 100 degree centigrade. So, in this category of the processes, since the temperature is maintained within the 100 degree centigrade. So, there is no metallurgical or mechanical damage to the substrate properties. So, this is one of the good side of the chemical and electrochemical methods, where the layer of the required material at the surface will be developed using the chemical reactions or using the electrochemical and based techniques for developing such kind of the layers or the coatings on the surface. Oxides of particular kind of the metals can also be deposited using this category of the processes. So, the good part of this category of the process is that during the surface modification, the temperature of the substrate remains below 100 degree centigrade, and which does not lead to any kind of adverse effect on the metallurgical properties or metallurgical characteristics of the substrate material, and there is no damage to the mechanical properties of the substrate as well as, and because of the lower temperature we will see the no distortion and the dimensional variation related issues. So, these category of the processes are good in that way. Then another category of the processes is thermochemical processes. So, in this category we have the carburizing, nitriding, cyaniding, boronizing. In these processes, temperature used is greater than 500 degree centigrade, and because of this there is every possibility for a change in the structure and mechanical properties of the substrate. So, the substrate characteristics and properties are expected to get modified when the component is processed through the thermochemical processes, because they are performed at a higher temperature for modifying the composition of the surface and near surface layers. Like carburizing will be increasing the carbon content, nitriding will be increasing the nitrogen content at the surface layers, cyaniding will be increasing both nitrogen as well as carbon at the surface layer, and similarly boronizing will be enhancing the boron content at the surface layers, and these will be forming the different kind of the constituents for enhancing the surface properties. There is another approach wherein the controlled surface melting is used using the high energy density processes, like we can use the laser beam, we can use the electron beam, or we can use the plasma arc, or even the GTA or the TIG arc is also used. All these are non-consumable processes where the consumable is fed in the heating zone if we want to apply or we want to deposit anything onto the surface. So, in these cases the approach is very simple. The surface which is to be modified is subjected to the application of the heat source, which is high energy density heat source. So, heat is applied over a smaller area, and heat is applied in a larger quantity in very small time over a small area. So, quick melting of the substrate layer is facilitated, and in this zone either we pre-place the alloying elements which is to be added at the surface, or we will be feeding in at the source or in the heating zone at the same time when heating source is applied. So, there can be like pre-placement technique where the alloying element to be applied or to be introduced at the surface layer is pre-placed, and then it is melted using the suitable heat source, or when the heat source is being applied at the same time we will be feeding the alloying element in very controlled way. So, mixing of both alloying element as well as the substrate material takes place in the molten state, and good metallurgical bond is created, and the chemical composition modified surface layer is formed in this approach. Only condition is that energy density has to be high, so that the faster melting is facilitated, and the melting of the base metal in combination with the alloying element to be introduced is realized. So, the controlled melting of the substrate as well as controlled melting of the alloying elements is done for proper intermixing of the two, so that the surface composition can be modified, and this kind of the approach is used for increasing the corrosion resistance by modifying the composition of a steel surface by adding like chromium, or it can also be used to increase the wear resistance by adding the hard constituents like tungsten carbides and other borides which are hard and brittle, or it can also be used to enhance the wear resistance by introducing the graphite at the surface. So, in these cases the near surface layer composition is realized through the controlled fusion of the material to be introduced and the substrate, both in very controlled way. Then there is another group of the processes which are called like pack cementation. Where the material enriched with the required element like chromium, aluminum, silicon, etc. So, these are the various elements. If you want to introduce, we will be using the process like chromizing or aluminizing or siliconizing. The material enriched with these constituents in powder form is kept in a chamber wherein the component whose surface is to be modified is also placed. So, these are the components whose surface is to be modified. These elements so the powder particles which are in contact with the components whose surface is to be modified under the suitable high temperature conditions, these elements diffuse into the surface of the component and change the composition of surface and near surface layers. Boronizing is one typical example of this kind of the pack cementation. Similarly, the solid carburizing is also an example of this kind of pack cementation, and likewise the chromizing, aluminizing and siliconizing is also used, where the material enriched with the required element in powder form is kept in a box. In that box we also put the components whose surface is to be modified, and then entire chamber is kept at a high temperature for some time, so that the diffusion of such elements at the surface and near surface layers can be facilitated to modify the surface composition so as to achieve the enhancement in surface properties. Now, we will be talking about the two processes based on this approach. One is the laser alloying and another is the laser assisted nitriding. So, in these kind of the processes, first of all we will talking about the laser alloying. So, here a laser is high energy density heat source, which means in very less time it can supply lot of heat for facilitating the melting of the substrate. So, there are two broad approaches in this laser alloying technique. One is like pre-placement of the alloying element at the surface of the substrate. So, in solid form, in powder form, the material to be introduced or the element to be introduced at the surface is applied first in the pre-placement technique. This can be applied in form of like paste, or the element is dissolved and then it is applied in form of the solution over the surface, or it can be thermal sprayed over the surface. So, thermal spraying gives the more uniform thickness or the distribution of the element which is to be applied over the surface of substrate, while paste is applied manually. So, there can be inconsistency as far as the thickness of the layer which will be applied. Once this layer has been applied over the surface of the substrate, will be applying this laser source, laser as a heat source onto this onto the surface where the required element has been applied, either the using the paste or using the thermal spray processes, and then use of the laser helps to melt both surface layers having the alloying element and the substrate, and thereby the molten substrate and molten alloying elements. Intermixing of both facilitates the compositional modification of surface layers. So, this is what is there. Once the surface layers melt and mix up with the molten base metal, and that in turn after the solidification will be leading to the surfaces of the modified composition. So, the laser beam is applied one by one over the entire area, like this is the surface. So, we will be applying the alloying element to be introduced using the paste or the spray process over the surface, and then laser beam will be scanning one by one the entire area to melt the alloying elements and the substrate, so that proper intermixing of both can take place, and we can have overlap between the different passes of the laser beam of like say 15 to 25%, so that proper mixing and uniformity of the composition over the entire surface area can be achieved. So, like this we can have the number of passes to cover the entire area. Now, what are the factors which are important as far as this laser alloying is concerned, and the factors which will be governing the surface composition? Like say we have applied the particular amount of the element, like say chromium we have applied on the surface, and the amount of the chromium that we want to introduce is say 30% at the surface. Just addition of the 30% of the chromium at the surface and melting with the base metal and getting mixed with the base metal will be reducing the concentration of the chromium at the surface. So, what we will be doing, basically if the melting is taking place up to a small depth, then same amount of the chromium which has been applied at the surface, after mixing with the base metal will be reducing the composition, say due to the mixing the alloying element which was applied at the surface was say 30 gram, and the melting of the base metal is also taking place say of the 20 gram, then what will happen, the total will be 50 gram in the metal in the molten state, out of which we have 30 gram of the chromium. So, in this case there will be 60% of the chromium, and if the more if the deeper melting of the substrate is taking place up to means if the substrate is being melted up to the greater depth, then the amount of the base metal will be more, it will not be 20 gram, maybe say the melting of the base metal is taking place up to say 60 gram, then total will be the 90 gram, 30 plus 60 will be leading to the 90 gram of the molten zone, and then if we will try to calculate the percentage of the nickel in this the total mass which we will be getting after the solidification, it will be 30%. So, there will be significant change with regard to the volume of the with regard to the depth up to which melting of the base metal is taking place. So, this change in composition of the surface layer is being influenced by the depth up to which substrate is melting. So, one simple criteria is used, like if this is the thickness which is being applied or there is a very simple way you have added 100% chromium, and obviously after the melting the base metal, the chromium at the surface layers will not be 100% because of the intermixing. So, there will be reduction in the chromium content. So, the chromium layer which was there at the surface 100%, after the mixing it may be reduced to 70%. If the deeper melting of the substrate is taking place, it may be reduced to the 40%. If the further deeper melting of the base metal is taking place, then it may be reduced to the 30%. So, this kind of the change in composition which is being influenced by the extent up to which base metal is melting or substrate is melting, this one is called the dilution. So, more is the dilution, lesser will be the concentration of the alloying elements. We always want that dilution is as less as possible. However, it is sufficient just to ensure that proper mixing of the base metal with the alloying element is taking place, so that the good metallurgical bond and good compositional modification can be facilitated. And this so this is the general approach. So, one thing which is important in governing the composition of the surface layer is the dilution which is happening due to the melting of substrate. Greater is the melting of the substrate, greater will be the increased in melting of substrate, greater will be the dilution. Means there will be reduction in the percentage or the concentration of the alloying elements. That is why efforts are always made to reduce the dilution level. This is the case. So, in case of the laser alloying, like say maybe 10 to 15% is the kind of the dilution which is observed, and if we are melting the base metal up to the greater depth, then like in case of the low energy density processes, low energy density processes like the TIG, plasma, arc. So, on those processes, the depth up to which melting of the base metal will be taking place, that will be greater, and which in turn will be reducing the alloying concentration and increasing the dilution. So, we have much better control over composition by surface alloying in case of the laser alloying. But if we use the plasma arc alloying, in that case greater depth of the melting of the substrate will be increasing the dilution and leading to the more reduction in the concentration of the alloying elements. Similarly, in the TIG arc process, where the TIG arc is used for melting the surface and surface layers of the substrate and melting of the alloying elements which have been applied either by the pre-placement technique or by other technique, that will be leading to the greater dilution and more reduction in the concentration of the alloying element. Another approach is that where the surface of the substrate is applied with the suitable heat source, maybe arc or laser. So, this arc or laser will be melting the base metal. At the same time, through the external source, the element to be introduced is fed in this zone. So, melting of this one is also facilitated. There can be coaxial feeding of the alloying elements which are to be introduced at the surface, or they can be fed using the suitable powder feeders at the surface, so that the composition of the surface and near surface layers can be modified. In this case, the no pre-placement is needed, but at the time when the external heat source is applied in form of the laser or the plasma arc, or in case of the TIG arc, in the heat source itself we have to feed the alloying element using suitable feeders, so that the melting of the both alloying element as well as the substrate can be realized for proper intermixing of the two, so that the required surface composition can be modified. One typical example for this kind of modification is where the nickel and the phosphorus nickel phosphate layer is applied on the surface of the aluminum silicon alloy substrate for increasing the wear resistance. So, in that case what we have, basically the substrate is of the aluminum silicon alloy, and at the surface we have the nickel phosphate layer developed by the controlled laser alloying. So, nickel and phosphorus concentration at the surface layers will be more through the controlled alloying for enhancing the wear resistance. Now, I will summarize this presentation. In this presentation, basically I have talked about the melting or fusion based approach for modifying the surface composition, and any high energy density heat source can be used for the laser alloying, wherein at the surface we apply the required element to be introduced, and then it is fused with the substrate using the suitable heat source, so that the surface layer composition can be modified. However, we have to keep a control over the dilution level during the melting of the substrate. Thank you for your attention.